All right, this is the Algebra 1, Unit 3, Lesson 5 video. This video is introducing just the concept of inequalities. And up until this point, we've been working with equations. And equations are statements that say that two things are equal. And that's what we've been kind of working with and solving up to this point. And so now we're going to look at types of algebraic relationships that are what we call inequalities. And so it's a way of saying that something is either less than or greater than something else. And so I'm going to walk us through some examples in the lesson and then show you what you're going to be doing in the practice problems. So what we're starting off with is just learning how to kind of think about inequalities. And when we read something in a word problem or whatever, understanding what inequality symbol goes with a certain concept. So we have four main inequality symbols. We have two that are greater than, and greater than or equal to. So you'll notice we have these two symbols. They both mean greater, but one of them is saying that it is only greater than, that's this one. And then the other one is saying that some number would be greater than or equal to. The way that most people kind of remember this is that the little symbol can be kind of made into like a mouth with like almost like an alligator thing. You've probably seen this when you first learned how to do this. And it always wants to eat whatever's bigger. So in a sense, we're saying that this symbol that's whatever's in this spot in a relationship is going to be greater. So if I had these symbols and I wrote X, this would be saying that X is greater than 14. Or if we have a symbol like this, maybe say A, this is saying A is greater than or equal to 3. So that's kind of just a summary of those two symbols, and those both fall under the greater category. All right. We also have symbols for less than. There you go, the opposite direction. And these are symbols for less than. So, for instance, if I said that B, this would read B is less than 4. Or on the other hand, if I wrote the following, X is less than or equal to 10. And so that's just kind of a summary of what these different symbols mean. On the number line, when we graph them, they're going to look like this. So like if I were to graph X is less than 14 or greater than 14 on the number line, sorry about that, let's get that down here. Sorry about that. That would look like this. I would, wherever 14 was on the number line, I would have 14 right here. Say there's other numbers this way and other numbers this way. X is greater than 14 would mean that the symbol would be an open circle at 14 with shading going above the line. So this would be the graph of that inequality. Now notice when there is just greater than, you have what we call an open circle at that number. Whereas in this next one, my graph would look like this. Again, we'd have wherever 3 was on the graph, and it would be greater than or equal to. So greater than or equal to would mean that there would be a closed circle at that number, followed by shading going above that number. So that would be the graph of A is greater than or equal to 3. On the other hand, if I had B is less than 4, say I have my number line here. I have 4 wherever 4 is on the graph. Numbers above and below. And then I would have an open circle at 4, and I would have shading going below that number, going down this way. So greater than is going to go to the right of the number. Less than is going to go to the left of the number. And then just to kind of finish us off, if I had this one, again, wherever 10 is on that number line, and then it says less than or equal to. So equal to tells me that there's going to be shading inside the circle, and it's going to go in the less direction over here. And that would be the graph for that. So this will kind of be a summary for you to remember which way the shading on the number line goes. The first thing they have us do is look at some descriptions and translate these into inequality expressions. So like, let's look at the example here. It says a speed limit of 45 miles per hour. So a speed limit would mean that that's the highest that your speed can be. So then we would say x is less than or equal to 45 because your speed would need to be 45 or lower. Okay, so the next one says a minimum GPA. Minimum GPA would mean that you have at least 2.5 as your GPA. Again, 2.5 would be the low. That's the minimum. And then everything above that would work. So then we would have x is greater than or equal to 2.5. I'm going to skip the movie grading one because that doesn't actually make sense. Height restriction at a theme park, over 4 feet tall. Over 4 feet. So it doesn't include 4 feet, so it would need to be greater than 4. And that's what we have right here. Home prices, price of homes for sale, 150,000 K and up. So it would be 150 would be the lowest and up. So that's greater than or equal to 150. And then it says diet plan, fewer than 2,000 calories per day. So fewer than doesn't include 2,000. So you need to be below or less than 2,000. That's kind of the first thing you're going to be doing. Let me show you what that looks like on your lesson. You are going to be looking at, here we go. It's statements like you see here. This is actually the worksheet you're going to be doing. It's attached to the lesson, so you need to just do these problems on a separate sheet of paper and upload the work to me. It says an acute angle is less than 90 degrees. I'm going to go ahead and underline the keywords. Less than. So I can tell you right now, and I'll give you the answer to this one. Less than 90 degrees, so it's going to be x is less than 90, and that would be the answer for that. Then they want us to take those answers and put them in an inequality or graphed on a number line. Well, we know 90 is the number, and it's going to be an open circle. Remember, it's going to be an open circle because there is no equal part to this, like we talked about over here. Remember that when it doesn't have the bar down here, it is open circle. When it does have the bar, it's a closed circle. Hop over here. And we see we have 90 and then less than. So we're going to shade this way on my number line. I'm actually going to erase that because there we go. Number line is going to go below 90. So these are what your answers should look like for each one of these questions. Like on the second one, the high temperature today will be under 85. That's your keyword. And then you graph down below. You must get 90 or higher. The water level will be 10 feet or lower. And then he is older than 100. So those are your kind of key phrases in each of those. You need to write the inequality statement like you see here in number 1, and then graph the answer in the second part. So that's one major concept from this lesson. And the other one is just taking inequalities and doing solving inequalities the same way we learn to solve equations. So I'm just going to go through an example of each type and talk through kind of the issues you need to know about. So what I mean is we've already learned how to solve something like this. we learned previously, we need to keep our equation balanced. We're going to subtract 3 from both sides, cancel that, and we get x equals 4. So everything we just did right there, we can do when we have inequalities. So it doesn't matter that it's an inequality and not an equal sign. All the rules still hold. So if I have the following, x minus 3 is greater than 2, then I know that all I'm doing is, again, I'm keeping my equation balanced, or my inequality balanced, and anything I do to one side of the expression, I have to do to the other. So we're going to add 3 to both sides. That's going to cancel, leaving me with x is greater than 5. So that would be my solution there. So this is what you're doing in the second part of your worksheet. If you see down here, they're giving you a problem and then a number line. And so the second part of my work would be to take that and to graph it on a number line. So let me go down here. Let's go ahead and just mark some points on here. So 0, 1, 2, 3, 4, 5, -1, -2, -3. You get the point. So I know that there's going to be an open circle at 5, and it's going to be shaded above the number up there. So that would be my graph. I know it's right over on the end, but your job is to solve the inequality. Once you get the final expression, graph it on the number line like we were doing in these previous problems, but now you're doing it with the answer to that inequality. So let's work out a couple more examples. So let's say I was given the following. X plus 4 is less than or equal to 6. All right, I know I need to keep the equation balanced, so whatever I do to one side, I'm going to do to the other. I'm going to do -4 on both. It's going to cancel that out and give me x is less than or equal to 6 minus 4 is 2. So that's the inequality that I have. Let's go ahead and draw our number line. So let's just label this right here. 1, 2, 3, 4, 5, -1, -2, -3, -4. Thankfully, you already have those on your graph for you. So I know it's going to be at 2. I see there's a bar right here. So that's going to tell me to do a closed circle at 2. And it says less than. So I'm going to go this way. I'm going to shade this way on my number line, going below 2. So what I really want you to know is that the key here is just knowing that you can solve these equations the same way you've been solving equations thus far. So let's jump over and do another one. Let's say I have x over 4 is less than or equal to 2. Okay, we know we need to solve by getting rid of this 4. To do that, we're going to multiply both sides times 4. And we're going to get, those are going to cancel, and we're going to get x is greater than or equal to 8. Again, just go and draw our number line. I'm just going to make a 0 go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. But we have x is greater than or equal to 8. I'm not going to label all those numbers. So we know we're going to go to 8. We know it's going to be a closed circle. That's because of this. And it's going to be greater than, so it's going to be this way. And so we've got our shading going that direction. So again, more of the same. Now we have one where we have 3x is less than 12. Well, again, divide both sides by 3, keep the equation balanced. That cancels out. It gives me x is less than 12 divided by 3 is 4. All of this work that I'm doing is exactly the work we were doing in the previous lessons, solving equations. So it's really nothing new. Just now you're doing the same stuff, but with inequalities. So let's go ahead and graph. 0, 1, 2, 3, 4, 5, -1, -2, -3. All right, so we will have an open circle at 4 and less than. So we're going to go this way with it, and we'll shade that direction. And so that would be my solution to that. So that's what you're doing in 11, 12, 13, 14, 15. Now, one note about 15. There is one difference. I'm going to make a new drawing for this. Dividing by negatives have a different effect on inequalities. And the rule is as follows. When you divide by a negative, switch the direction of inequality. For example, if you had the following: negative 3x is less than 15. Again, if I'm solving this correctly, I'm going to divide by negative 3 on both sides. When I do that, I have to do something to this. Because of the negative, this is going to change to go the opposite direction. These are going to cancel, giving me x and negative 5. So what you need to notice is that the inequality symbol has switched from less than to greater than, and now I would go and graph my answer. But the key here is when you divide by a negative, switch the direction of the inequality symbol. You must do that anytime you divide by a negative. That's going to affect your answer in number 15 and possibly others. All right, so I'm going to start another drawing and do some two-step equations so you have lots of examples. Again, none of these are new methods, just looking at the same stuff we've been working on, just getting you guys some more practice on solving inequations and inequalities. So we have 4x minus 3 is greater than 5. Remember, this is the division of our problem. So we're going to add 3 to both sides. And that's going to cancel, giving me 4x is greater than 8. Go to our next step. Divide both sides by 4. That's not a negative, so nothing happens with the inequality symbol. And we're left with x is greater than 2. Again, all this process is the same. Doing the opposite to cancel out the 3 is add 3, do it to both sides, and then divide by 4 to get rid of the 4 times x. More or less the same as what you've been doing in the previous lessons. So let's say we have the following: x divided by 2 plus 7 equals 13. Well, again, we need to do, I did equal. Let's change that to greater than or equal to. And let's say we're going to subtract 7 from both sides because we need to cancel that 7 out. That's going to be 13 minus 7 is 6. Symbol is going to stay the same. And then we have x divided by 2. In order to get rid of that 2 on the denominator, we're going to multiply by 2 on both sides. To cancel it out, x is greater than or equal to 12. All right, let's do one more example, just so you can see all the different types of problems you might come across. 4 is less than 3. Okay, in this one, we actually need to multiply by 4 first. So that cancels that out. Multiply by 4 on both sides. And we get 5x minus 3 is less than 12. There was no division by negative, so we just keep going. And now we just have 2 steps to solve. We're going to add 3 to both sides. 5x is less than 15. Divide by 5. Divide by 5. X is less than 3. That's pretty much it. So I've given you a ton of examples. Use those to your advantage. I've done examples much like the ones you have here in 16 through 21. That's the end of that lesson. So make sure you're doing the problems from this worksheet, and you just send me some proof that you did that. Send me a photo through email, through chat. You can upload it to the actual Buzz, whatever it is that you decide. But that's it for lesson 5.